So how many of you have ever used web page test? I know. So I'm going to introduce you to your new favorite superhero. Pat Meenan is actually the creator of web page test. To me, that's... They say never meet your heroes, but I feel like he's a good exception to the rule. Pat is a great guy. He's actually currently a software engineer at Google, though he's worked at Cloudflare, Meta, Catchpoint, Google again, and maybe another one again, and even AOL, remember? You've got mail. He has worked in web performance for 25 years. His web performance career could have a career of itself. And he created Web Page Test, our favorite web performance tool. So everyone, please help welcome to the stage Pat Meenan.
Thank you. So I'm not here to talk about web page test, unfortunately. I love it. One of my favorite tools. I loved working on it. But I also spend a lot of my time, right now I'm at Google working on Chrome, working on loading performance again. It's sort of, I did my great tour of FANG, working on performance from sort of all sides of things, from the client, from the CDN, and from the browser, and from the servers. And so went back to Google because there were a few things that I wanted to get done. Fetch priority was sort of number one. We had worked on it when I was back there in 2018. We finally got it shipped last year. So please use fetch priority if you're not already, especially on your LCP images. It will it's a cheat code for Core Web Vitals. But today I'm talking about sort of the new next thing that we're working on. It's actually ready to be used. I'm really bad at naming things. You know, something that tests web pages is called web page test. This new project we're working on is compression dictionaries, because it's dictionaries for compression. So this whole presentation, everything in it, all of the tools and everything is on useasdictionary.com. So you don't have to really take any notes on any of the slides, just sort of soak it all in, and it will all be available here for you if you want to go revisit any of it. Yeah, again, I'm really bad at naming things, and just to be safe, I named it a whole bunch of things because I'm really bad at buying domain names too. So yes, I have problems, lots of problems. So first, I wanted to make it clear, it is available today. So I say it's the next great thing we're working on. There is the little asterisk about it being an origin trial, and I know we've been burned a time or two on Chrome origin trials. This is one of the things I'm staking my career on it actually shipping in one form or another. The origin trial is to help shake out sort of, are there any rough edges with the developer experience, with the serving infrastructure? Are there things that we can make better to make the ergonomics better? And for that to happen, we actually need you to try it and not just work off of our assumptions on how we think it will work in the infrastructure. So, you know, I was really scared when I saw Mark was the first talk here, and following Mark's awesome design skills, my deck is going to look like a Ryan super optimized website. It's like super bare, and I spent, I want to say, 10 hours on Midjourney, DALL-E, Google's image generator, trying to get it to generate an image of a shrink ray. You wouldn't think it would be so hard. And it generated all sorts of really pretty pictures, but then I went back to my old school and just Google searched shrink ray, found the best cartoon I could. And this is sort of what we're trying to do to the resources on the web. Provide tools to make the resources smaller so you can ship more excellent experiences. What you do with them, you know, it's up to you. Ship more JavaScript, it's going to happen anyway. Hopefully this enables it or sucks up some of the impact of it. So I'm not a compression guy. This is sort of like the high-level overview of how I see compression working. If you've got any compression nerds in the audience, you know, I'm probably way off on the details. But basically, right now, today, when you're serving a resource and you're using gzip or Brotli or zstandard or whatever the latest and greatest is, you have the version of your JavaScript, HTML, CSS, whatever text file, and the way it gets compressed usually is It will scan through as the file's coming through, and if it sees something that it saw before, it can go, hey, I'm going to replace that with a token that stands for what I saw before. And so the first time it sees function and the contents of the function and console log, it hasn't seen all of that before and it needs to spit it out. But the second time it sees all of that common stuff, it can replace it with something much shorter, and you end up with a much smaller compressed file that, when it goes through the decompression, gets reinflated to what it was originally. All dictionary compression is a separate file that we call the dictionary that has the common things that you're likely to see in the files that you're trying to compress. And so instead of having to have seen something before, the first time it sees it, if it's in the dictionary, it can replace it with something that's a token. And you end up with much smaller files because you don't need the first view of the uncompressed content. So the common parts of your code, your resources, your HTML, whatever, if it's in the dictionary, it can be compressed out. And you have this side file that's the dictionary. And so, fancy name, compression dictionaries. So we're going to try and bring it to the web. And I wanted really early on to explain why you should care. We'll get into the details of how and why, but the impact, it's not like the next tweak to Brotli where we get a few more percentage points. Here we have on the chart, the blue ones are gzip 9, the maximum gzip level. The red is what you get if you go to Brotli 11. And the yellow version is what you get for these resources in particular when you use a dictionary. There's generally two types of resources we're going to be talking about. Static resources, things that are part of your build or whatever, JavaScript, CSS, WASM. This is assuming compiling or compressing the static resource with a dictionary of the previous version. So let's say you've got a rich JavaScript app that has the hashes in your file names to get good caching, for example. And so you've got your version 1 and your version 2 of your resource. It hasn't changed that much between your two versions, just whatever you've done to fix or add features or security fixes or packages that you've updated. This is using the previous version of your JavaScript file as a dictionary for the new version of your JavaScript file, effectively giving you delta compression when you're delivering to the clients. And so the YouTube desktop player, for example, updates multiple times a week. It's, unfortunately big. It's 10 megabytes uncompressed, 1 megabyte at the best Brotli that we can get. It's somewhere on the orders of 100 to 200 kilobytes if we can do week-over-week delta compression using dictionaries, just delivering the updates. The Vercel, for example, their application JavaScript week over week, it's almost compressed out. It's 96% smaller if you're just doing the delta updates. And Filament is just a WASM app that I happen to be able to find month-over-month releases, I believe, that were fairly big, substantial changes. I think they changed the version of FFmpeg that's actually in the WASM bundle. And we still get 45% smaller than the best Brotli compression we can get. And we start talking about big, rich web applications like Photoshop on the web, for example, that's 50 plus megabytes of WASM that you don't download and install, but somehow you have to get it into the browser, and I'm not sure exactly how you're doing that if you're not downloading it. But so week over week with Photoshop updates, for example, you wouldn't have to re-download the whole 50 megabyte application, you just download the delta. And so that's what we're here hopefully encouraging adoption for. It's not just static resources, so HTML content, using a generated dictionary, you can take all of the header of your page, the head of your HTML, the footer of your page, the general structure and layout of your pages, your data URI image placeholders, for example, all of that stuff that's common across your skeleton pages can go into a dictionary. And when you take that dictionary and apply it to the HTML pages, you can get, even for dynamic content, significant savings. Google search, optimized to the hilt. We get 40 to 60% smaller pages if we're doing dictionary compression using a custom dictionary. Etsy, I know you're in the house. 21% of the size, so 80% smaller for the product pages if you use a dictionary that has sort of all of the common parts of the Etsy page. So going page to page during a session visit, you end up with much smaller HTML delivery. Bloomberg, I know it's not the terminal, but the Bloomberg website was kind of amazing that you get almost 90% smaller on the HTML, which is generally the hardest thing to deliver and shrink, and most important for performance. Sort of trying to think the other angle, there was another, I'll get to it in a little bit. So we have a little bit of a deja vu here, especially for the older timers in web performance in the house. We've been doing this for, I want to say, the better part of 15 years. SDCH was a thing in Chrome, I want to say back in 2010, 2012 timeframe. Search, eBay, there were a couple of users of it. It was something very similar. It was HTML specific. But then that was right about the time that the crime and breach attacks started to happen, and we found out about side channels and compression. And it turned out using dictionary compression, at least at this layer, was a vulnerability, and we had to turn it off. And so from that point on, we've been doing a bunch of fighting trying to get delta compression effectively to the web in a privacy-safe way. HTTP2, it was kind of funny to see the Twitter flame war a little bit that flared up about a month ago. It's time to unbundle all of the things now that we have multiplexed protocols, HTTP2, HTTP3. When we first launched HTTP2, it felt like it would be a good idea. Hey, we can deliver a whole bunch of resources in parallel. We don't need to bundle all of our resources. Turns out that's wrong. Compression is one of the big reasons. When you compress all of your resources, it's a lot smaller than compressing each one individually. But there are also browser restrictions and overhead. If you have 1,000 requests, the browser has to do 1,000 checks in disk cache to see, do I have these things? And that's much slower than a single request to see if the bundled version is available. We did try to solve it, at least the compression side of things, doing cross-stream compression in HTTP2. The security privacy guys took one look at it and went, nope, nice try, try again. And so the next attempt that we had, and this is much more recent, I want to say last year, web bundles for taking all of your sort of JS that's part of your modules and let you reference JS within the zip file as separate resources. It solves the compression problem. It lets you update individual resources within a bundle, but it had really bad developer ergonomics. You had to change how JavaScript was on your site. And that's kind of a big hill to push up, especially if it doesn't have browser support. And so this is the latest, and we think, we have talked to the privacy and security guys beforehand this time, by the way. And so they've all gone, yes, we can't find anything wrong with it yet. But there have been Google, Facebook, Apple, Firefox, and W3C security and privacy teams have all looked at it. So we're pretty confident it's going to fly. So the actual resource flow, what does it look like? The static resource flow is going to be sort of the easier case that I'll talk about first. And this is when you have one version of a file, and you have a new version of the file. And when I say you, I mean in the browser cache of your end user, they have the version of your JavaScript from, say, a week ago or a month ago in their cache. You have since released multiple versions, and you're now on version, well, in this example, version 2. So I guess you've released one new version. And we're going to talk about how you deliver that to them specifically. The only changes between the two were you updated a couple of lines of code or something like that, and the actual delta between them is much, much smaller than the actual file itself. So how this works, the first time they come to the site, or the first time they're getting the first version of the app, something on the HTML page will have a script reference to v1 or /app/v1/main.js. Or it can have a hash of the file somewhere in the file name. That file will respond with the use as dictionary, hence the domain name I purchased, because I'm really good at thinking of names. And it provides a match path of what requests this file can be used as a dictionary for. Because when you properly version your resources, main.js is not going to be the same request for version 2 that it was for version 1. And so this lets you say, hey, all of the files with this pattern are actually the same file, they're just different versions of it. So go ahead and use this for any future requests for anything that looks like a main.js request. And at some point in the future, when you come back and visit, the browser now knows that we've got a request for v2 main.js that matched the pattern that we have for a dictionary that we now have in cache. And so it announces to the server, hey, I've got an available dictionary, and it sends the SHA-256 hash of the dictionary contents. It's important, we couldn't sort of send just the file name because we wanted to make sure what the client has is actually the same thing the server has. And so it sends the full hash of the dictionary. And yes, I know SHA hashes are a lot longer than that, but they wouldn't fit on the slide. And it also includes, at least right now, SBR, which is shared broadly, in the accept encoding. It will also, as of Chrome 119, it also includes ZSTD-D, which is the Z standard version. And so when we originally did a lot of this work, it was going to be shared broadly. Z standard was released since the time that we started doing shared compression work. And Z standard also supports dictionary support. And Chrome, as of, I want to say 116 or so, has support for Z standard. And so now Chrome also has support for Z standard dictionaries, as well as broadly dictionaries. So whatever your flavor of compression you like to do, we'll accept either one. If the server has a delta compressed version of main.js that was compressed with v1 as the dictionary, it can send back just that delta with a content encoding SBR saying, hey, this was delta compressed. And the much smaller version, the browser will automatically decompress it to be the full version. I will say this solves the delta compression delivery of JavaScript. The browser is still running the full version, or compiling, parsing, running the full version of the JS. So don't go hog wild with the amount of JS you're sending down. The uses dictionary header, response header, has two parts to it. Match is a wildcard. You can have any, like you can have main.js, app.js, a whole bunch of dictionaries on your origin if you want. If there are multiple matches that have the same pattern defined, the one with the longest match string wins. And it's under the assumption that this is the more specific. Like if you have a generic dictionary for /star for, hey, I've got a dictionary that works in general well for my whole site, but then I have an application-specific dictionary, you can override basically the site-wide by having a longer match path. TTL is a specific time for the dictionary itself to live as a viable dictionary, independent of the cache headers and the cache time. So you could cache it forever, but say that you only want the dictionary to be used for a year or a week or a month. The main reason for separating those is going back to the request headers. So when the client requests the resource and you deliver the delta compressed version of it, it has the available dictionary header and the accept encoding, both of which the response is going to vary by the available dictionary and accept encoding. And so that introduces into your CDN caches or any of your caches in the network separate copies of your resource for every client combination of headers. And so if you update your resources 3 times a day, and you make it available for a year, you've got close to 1,000 different versions of the sec available dictionary hash that could be in the wild that will end up causing you to have 1,000 copies of your resource in your CDN caches, and they'll just start throwing random ones away. And so the TTL specifically is to let you sort of fine-tune based on how often you release, how long back you want clients to be able to do delta compression based on sort of what your usage pattern is for clients visiting frequently, and balance that against how many copies you want to be in your CDN caches or your edge caches. And so this is actually changing to default to a week, just to make sort of everyone a little more comfortable on the CDN website of things about us not defaulting to blowing out all the caches on the internet. In a sort of static resource build environment, one way this could work, it's not sort of the only way, is at build time, you get artifacts, main.js, other files.js, and you have the previous versions of your releases available somewhere where your build tools can reach them. And after you've done your main build with your bundling and everything else, you can run a Brotli or a zstandard command line that you take the hash of your v1, your older file, so that you know what the dictionary signature is going to look like for that as a dictionary. And you basically tell Brotli, compile this new version using the old version as a dictionary and name it with the hash in the file name. And so what that gives you at the end is you have your main.js as well as versions of your main.js that are delta compressed against previous versions that have the hashes in the file name, and they're just sort of all sitting there in your release directory available to be used. And when the browser requests it, the Edge server, your application code, can basically go, hey, it has this dictionary available. Do I have a main.js file with that hash and SBR available to send down to the client? And if so, just send that file instead of the original resource. If it requests a dictionary that you don't have the hash for, just send the whole file. It's perfectly acceptable to not send content encoding SBR. It's completely progressive enhancement. It's just a miss on the dictionary, and you send the full resource. It's worth noting that in this case, your CDN will be caching 2 copies of main.js, one without a dictionary and one with the AABBCC key, since we're varying on available dictionary. So it's not a complete no-op, but it definitely nothing will break. On the dynamic resources, so that was the static case where we're serving versioned resources. I use JavaScript in the example. CSS is really easy to do as well. It doesn't even have to be text resources. WASM is still sort of a text format, but that works. But you can also do binary files if you're feeling really sadistic. I did experiment, and this is more in the dynamic case with JPEGs, for example. If you've got a color profile that you happen to be embedding in all of your JPEG images, in theory, you could pull that color profile out into a dictionary and use that to compress all of your JPEGs further, for example. So the compression doesn't care. They're byte streams. If you have anything that happens to be common between 2 files, you can use that to reduce the transfer file. In the dynamic case, this is more things like HTML, but also API calls, JSON. So if you're making GraphQL calls, JSON is really verbose. You've got all of the keys, all of the structure, a bunch of default values. All of that stuff can go into a dictionary and be compressed away. So your API calls can effectively become binary transfers. And so in this case, this is sort of a bunch of different product pages visualized with my awesome graphics skills, where the green and blue parts are sort of, the green are common on all pages, the blue parts are common on a few pages. You take sort of anything that might be common at all, put it into a dictionary. How you do that, we'll talk about in a second. And then just the parts that are different, like in a search results page, for example, the actual search results, but none of the skin around it, the search bar or anything like that, become what you actually deliver to clients. Sort of the key to all of this is any response, any HTTP response can be used as a dictionary. For any other resource. It really depends on just defining what the product path or what the match path is for where you want that dictionary to be applied. It doesn't have to be a previous version of the same file. It can be a custom file that you build that happens to work better for the types of content that you're trying to serve. The real key in the dynamic case is just, how do I get that dictionary to be fetched so that it can be set and used as a dictionary? Prefetch, preload could have worked, but then you have side effects on other browsers that don't support dictionaries where it would be downloading the dictionary and never actually doing anything with it. And so, yeah, so this is just where it gets reused against all matching fetches. It doesn't really know or care about what's being fetched, just that the path matches what was advertised as a dictionary. And so what we really needed was just a way to trigger a dictionary fetch to be able to seed it. And so just added a new type of link. So instead of link rel equals preload, it's link rel equals dictionary, and you can point it to a dictionary. It can be either in HTML as a tag, or it can be in HTTP headers. And so this is how you would trigger your first HTML view, for example, would still be compressed using traditional compression. It would have the link tag in it that would cause the browser at idle time, sometime after the page load has happened, to fetch the dictionary, make it available, apply the path, and all of that. And so future HTML navigations, if they match the path that's advertised in the dictionary, can be compressed and much smaller. And so, yeah, I mean, if you sort of think about it, what we're doing here is effectively giving MPAs the capabilities that you get with SPAs, where you deliver all of the shell in the dictionary, and the content that's specific to each one of your pages is all you're downloading each time without actually having to do anything SPA or otherwise. It just gets compressed away. And so as you're navigating through product pages or search results, you're just downloading the differences that you need for each one of those pages. Where we are with CDNs. So CDNs in particular like to generally normalize the content encoding, the accept encoding, do the compression. So there's sort of two phases to it. It's the don't break things and let us do compression dictionaries without support of the CDNs, but so that the accept encoding can flow through. And every CDN I've tested allows you to do that. Some more easier than others. All of them require slight tweaks to the configs just so that they don't strip out the accept encoding of SBR, and so that they allow it to pass through the origin. Most of them, once you say content encoding SBR, they'll go, hey, I don't know what to do with that, and just pass it through. And some of them you also need to manually say that we can vary on the dictionary header and the accept encoding header, because they tend to not like to vary on accept encoding, just because there tends to be a lot of them. All of this is available on the usesdictionary.com/CDN, or there's a link on Uses Dictionary that has the details for these three CDNs at least on what you need to tweak to get it to work. Like Fastly is just a one-line VCL change, for example. So it's not maybe as onerous as it may seem. I know Akamai is in the house. I'm sure, I don't personally have an Akamai account and a rep to work with, but I'm sure it's really easy to flag somewhere to just not mess with the content encoding and allow it to go through. So there are, some restrictions on what we can do with dictionaries to keep the privacy and security people happy more than anything. It's one of those, over my time on the web, it's like, why we can't have nice things, the entire reason today is security and privacy. We would be building all sorts of cool things. I mean, it would be horrible for the users and the ecosystem, but the technology we could have if we didn't care about privacy would be awesome. But we're not in that kind of world. And so the main requirement for dictionaries is that they need to be same origin to the resources that they're compressing. And so if you want to use a dictionary on your HTML, it needs to be served from the same origin as your HTML, just to make sure no one's like hijacking other people's content and attacking it with an attack dictionary. And they need to be fully CORS readable by the document they're being loaded in. The main reason there is compression is a giant side channel attack for exposing the contents of the compressed resources. And so I don't know how the hell they do it, but the security researchers are able, using just compression and some control over what's in the streams, to actually extract the contents of what's in the compressed encrypted streams. And so the main workaround there is to say, that's fine, it's all readable anyway, so you can't attack something that you can just read. The restriction there is if you do have something that you want to protect from being readable from the documents, you can't use dictionary compression. For the vast majority of things, your JavaScript, your CSS, your API calls, that's not a problem, but just be aware that either means your resources that you're compressing are same origin as the document, or that they're cross-origin, and the cross-origin response includes an access control allow origin that covers either star or the domain that's making the request from the referrer. And the dictionaries are partitioned with the caches of the browser. So you're not going to have a mega uber HTML dictionary that you can use across 100 different sites, for example. So like Shopify, where you have all of the different vendors, each vendor is going to have to download the dictionary because they're running on their own domain. You can't have like a Shopify one dictionary gets used from Allbirds and ProClips, two places I happen to buy stuff from that are Shopify clients. And so basically everyone's on their own island for delivering their Delta updates or their dictionaries for their resources. And those are really sort of the only two boundaries that we have, but those are enough to make it so that it's not attackable and so that we get to have our nice toys. There are changes. They are coming. We're in the standards process, and so the standards process is basically a giant bike shed of people going, I don't like that name, I think it should be named something else. And then going, why didn't we name it this other thing instead? And so SBR was what we had as a placeholder. That's being changed to BR-D, which is broadly with dictionary, to match Z standard with dictionary. But what Chrome has in it today in 1.19 is SBR. And we didn't want to change it because we're not done bike shedding yet, and the names may change again. So we'll wait for the names to settle before we change. But if you do origin trial, these are the things that are likely to change during the origin trial. And it's just things like the text strings that get used for the headers and for the content encoding. So nothing that breaks the actual flow and how things work. That we're pretty solid on. Sec available dictionary in the spec has already changed to available dictionary. They didn't think it needed to be protected with a sec header. And so if in fetch, you decide you want to break yourself and add an available dictionary that the browser doesn't have, go at it, break yourself. It won't actually break anything that the browsers care about. You'll just get responses that may or may not be decompressible by the browser. One of the things that we didn't go out of the gate with yet that we've noticed we probably need is beyond just a path matching, destination matching, so that you can specify a document dictionary to be used with HTML that isn't also sent for all of the image requests on your origin, for example, or for all of your JavaScript resources. So that if you do want to specify a /* path and say, I want this dictionary to apply to all of my HTML across my entire site, you'll be able to do that with match dest document. You could, in theory, also do match dest JavaScript or script and style. Those make a little less sense because generally we'll be doing path-specific, file-specific Delta updates for those. But if you do have sort of a JSON dictionary that you want to apply to all of your JSON requests, you could apply that to fetch and specific paths. The match wildcard that we have in place right now is probably moving to URL pattern, which is used for service workers and speculation rules and sort of the direction the web platform is generally moving if you want to specify sort of matching, URL path matching semantics. And so we're likely to take the match and split it into two. One part is for the path part of your URL, and one is for the query params search part of your URLs, and split it into two pieces. Still support wildcards. It won't be that much different. and it'll default to probably a wildcard for the search. So if you just have a specific path and ignore query params, that'll be in place. And as I mentioned, the TTL default will be changing from a year down to probably 7 days since last use. Instead of right now, it's 1 year since the dictionary was originally written into the cache. The 7 days from last use will basically mean any user that's been to my site in the last 7 days, even if they got the dictionary a year ago, will be able to do delta compression. And so as far as the tooling goes, and this is probably where things get more interesting, Z-Standard, as far as the compression side, all versions of Z-Standard support external dictionaries. Whatever you get in your CLI, apt install, or however you download it, it should just work for generating dictionary-based compression from the command line or from building into your servers if you want to call the APIs directly. Brotli 1.1.0 was released, I want to say in September, maybe August. So it hasn't made its way into all of the apt installs. You may have to build from source to get a version of Brotli that compiles or compresses with external dictionary support. Just check if the dash capital D command line property exists. If not, it's not that difficult to build from source. You just clone the repo. If you install Basilisk, it's an automation tool for building with Bazel, which is the open source version of Google's Blaze, which I guess the Brotli team used for the build. And you just run build Brotli, and you have a command line version of the latest code. The Brotli repository includes a dictionary generator, which will probably be your best friend in the case of the HTML dictionaries. What you can do, and it's built the same way, it's just part of the same Brotli repository, it's just in the research directory. And what you can do is you can give it a whole list of files and say, generate me a dictionary based on these files, and it will extract all of the common parts of the files for you into a dictionary of the size that you specify. And you can say, make it no bigger than 1 megabyte, or however big you'd like your dictionary to be. The dictionaries, when you serve them, can be served compressed. So like a 1 megabyte dictionary, maybe 100, 200K on the wire when you serve it. So don't get too discouraged with building large dictionaries. I do have a tool on usesdictionary.com, actually a couple of them, and it's linked from there, that basically hosts the dictionary generator for you. So you can give it a whole bunch of URLs, I think up to 100, yeah. And it will generate a dictionary for you on my server in my basement, so please don't abuse it too hard. And if it's going slow, that's probably why. And it will generate a dictionary for you of the size that you request and let you download it and use it for whatever you want to use it for. One of the other things that it will do, and it's how I got the estimates for the improvements on like the Etsy sites and the Bloomberg sites, is it will test the effectiveness of dictionary compression on those URLs that you provided. It does that in a painfully obtuse way of, for each URL that you specify, it generates a dictionary from all of the other URLs, excluding that one, tests to see how well it compresses, and then does that for every one of the resources. So it generates 100 dictionaries if you're testing 100 URLs to test the compression of each one, because it would be cheating if you had the contents of the URL that you were testing in the dictionary that you were testing the effectiveness on. So it is a fair test for how likely your pages are, how much your pages are likely to compress. It also, you can specify a user agent string. One of the important things sort of to be careful of when you're generating the dictionaries is to not include any user private data in them. And so if you were at your app server, for example, to just observe responses, save them, and generate a dictionary from them, or from a CDN man-in-the-middle kind of place, just sort of observe the requests flowing through and generating a dictionary, you could include some private data by accident. And since we discussed dictionaries are publicly readable for anyone that has access to them, you've just put private data in something that's readable. The other benefit to this is it fetches all of those completely anonymously from my server. So there's no way, there's nothing that's not open to the web in those dictionaries. Coming soon, I didn't have enough time to complete the work on it. I have a WASM build of Z standard that can run in a Cloudflare edge worker. So if you don't want to do the dynamic compression for the HTML case on your origin, you can run it on an edge worker on your favorite CDN. I just happen to be using Cloudflare because I'm familiar with their edge workers, but I think most will run WASM. And so what you can do is have your HTML dictionary on your edge, as well as WASM and Z standard, observe any HTML flowing through, and when the client has the dictionary available, just automatically do compression on the edge. And so you can deploy it without having to build it into your actual application or without having to wait for CDN support. And to be fair, all of the CDNs are looking at what does it make sense for us to do as a value add for doing the actual compression, but you're not necessarily beholden on waiting for them to implement it. I mean, I feel a little dirty about running compression in WASM on the edge of a CDN, but it's what WASM's there for. As far as the current status, I did mention it's in Origin trial in Chrome today, so you can use it today. Please do. Feel free to ask me directly if you have any questions, or there is feedback on the Origin trial where you can let us, and please do let us know officially how it integrates with your build system. Does it work with your flow? Are there particular places where it caused problems where we can make it easier with different patterns or headers or anything like that? There is an IETF. The HTTP working group has adopted it as a standard. There's a draft. We're talking next week at IETF about moving that on. It will hopefully be an RFC for all of the HTTP layer headers, everything except for the link fetch tag. There's a W3C explainer. All of this is also linked on the Use As Dictionary site, so you can read the actual specs. The explainer is much more approachable and has sort of the layout and the history and whys. The W3C, we're probably going to take the link header and link meta tag, specifically dictionary, as part of the HTML spec and feed that into those specs. So we're crawling a few different specs, but there haven't been any objections. All of the browsers are positive on the change, so we're not expecting any problems doing that. It's just time going through the bike shedding and spec writing process. It does take a village. I'm up here talking about it, but I'm not like the one who's done all of the work. I don't think I've written any code for it other than sort of my tools and stuff. Yoav sitting right here and with his mug right in the middle. He's been fighting this problem since SDCH, and he was the one largely behind the HTTP2 attempt and butting heads with all of the privacy and security teams and came up with the original idea for this. I'm just largely working through the spec process and working with all of you on it. There are teams at Chrome working on the implementation, all of the browsers, all of the CDNs, even a bunch of customers have sort of taken a look at the specs, the headers, to see how they work in their ecosystem, just to make sure there aren't any problems with it. And so thank you, and I'll be really happy when we get back to one social network. These are like all of the ones, not all of them are available in Europe. I'm really looking forward to Threads being available in Europe, and then we can maybe have another place to talk about things. I think that's it. Oh, and because I don't think Europe lets us have the neon-colored Mountain Dew that we can get in the US, I brought some with me.
Trying to make a few extra bucks
sure
on the side.
It's full of all sorts of carcinogens, but
But we need those to grow, right? Thank you, Pat. That was really cool. We have a lot of questions, but we won't go through all of them, but we'll at least cover
I will
some
be
of the
around
highlights.
all night, so
Exactly.
feel free to corner me.
So will this be suitable for on-the-fly compression? For example, Brotli 11 is too slow and CPU intensive, or is it something that you might do at the build step instead?
Yes, sorry, I forgot to mention it on my HTML page. So on the Brotli page for static resources, I used Brotli 11, which is sort of the extreme, use all of your CPU and your friend's CPU to compress stuff. Z standard, I don't know why they can't agree on a scale. Brotli goes to 11, Z standard goes to 19 or 20 or something like that. I used Z standard 10, which is sort of in the middle and very CPU friendly. Z standard all the way down to 3. So Z standard will use dictionaries on all compression levels. I wouldn't recommend doing it on 1. At 3, you end up seeing a lot of the savings. By the time you get to 10, you've reached sort of the maximum savings, and then beyond that, you're getting the incremental tiny wins that you're used to seeing from like the last couple of percents. Brotli, anything below 5, at least on the command line tool, won't use dictionaries at all. So you have to use Brotli 5 or higher to get any benefits from dictionaries. In the static case, you might as well use Brotli 11 and get every little bit. But if your build system, you don't want to use that much CPU for whatever, you can use slightly lower. But yeah, Z standard is probably the way you want to go in the dynamic case. And we're talking about that in general anyway. I mean, the Brotli compression team will probably kill me, but the consensus seems to be that Z standard is lighter on CPU for equivalent compression than Brotli. May or may not be true. With dictionaries, it's definitely true because Z standard at lower compression levels still uses dictionaries, whereas Brotli doesn't currently anyway. But yes, absolutely, totally applicable to dynamic, even at low CPU usage. The main issue you're going to have in dynamic cases is the dictionaries. You just need to have them in application server memory or in web server memory. If you're in a CDN case and you have thousands of clients, then you may have thousands of dictionaries that you have to worry about keeping in memory on the edge. The compression libraries are really good about shared memory and letting multiple responses all use the same shared dictionary memory, so you don't have like a copy of it for every response you're working on, but it does add a little bit of overhead. Sorry, that was a very involved answer, but it was a good
excellent
question.
I am sure they wanted all of that. Have you considered, this actually came from several people. I'm going to apologize in advance because it's a little tough question for your Chrome team, but have you considered shipping certain generalized dictionaries with Chrome? Like, for example, a dictionary that can be used for generic JSON responses, or a React dictionary tuned to common React syntax?
So Brotli itself has a dictionary in it, which is largely why Brotli compresses
cool.
so well. And yeah, so it has a custom dictionary built from how the web looked at the time Brotli was shipped, which may have changed a little bit since then. We have talked about in the future, and I'm not committing to any of this, it could make sense for the browser to advertise some set of known dictionaries that compress certain types of content well, maybe in the same header, maybe in different headers, that servers could then opt into using. I'd say that's probably we want to get shared dictionaries working first, make sure they work well, and that the origins are in a good place to be able to do dictionary compression. And then we can talk about, is there something that makes sense to ship that has... So the problem with things like React and some of the frameworks is you've got version-specific things, but if there's sort of a general template of things that how the web looks today, ES6 API calls that people are calling, or common other things that should be in a new version of a web dictionary, it could easily make sense to have some of those available. But yeah, it's a good question, because it could have some serious impact across the web without having to have everyone download dictionaries.
There's also unintended consequences, though, like how do you choose which ones to use, and how does that
and are you favoring like React 2 by having a built-in dictionary that's not available in a newer version of React? And it may make sense where there's some repository of well-known dictionaries that sites can opt into, that like the browsers could download into a shared cache, for example, so we don't have to partition it by site. And maybe something like that makes more sense.
A trusted shared cache.
Something like all of the browsers could agree upon, hey, let's add another thing to the well-known list that is downloadable at runtime or something like that.
Do you know if this works with service workers?
I mean, it doesn't break service workers in any way. Service workers don't sort of facilitate the dictionaries in any way, because by the time the resources have gotten to the service worker, they've already traveled the network. You could have, in theory, implemented dictionary compression in a service worker, but as far as service workers themselves, the responses that are dictionary compressed are transparent to the service. By the time it gets to the service worker, it's already been decompressed, and it's the full version of whatever v2 of your JavaScript or your HTML is. And so it's seeing the unmolested full version of the content. And so it doesn't break service workers, but there's nothing sort of special that service workers brings to the party.
And then how do you use multiple dictionaries? Is there a way to map them?
Yeah, so the match path and now soon the destination lets you specify as many dictionaries as you want. Like if you have 10 files in your build, for example, and just looking at JS and CSS, for example, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can have the match path be /*1/*2. And all 10 of those will be dictionaries available for any requests that match the URL pattern. And so you can have as many dictionaries as you want, as long as you can specify the things that they apply to using the patterns. Now, I will say each dictionary can only apply to one pattern. So you can't say this dictionary at this URL needs to cover 3 different patterns. You would actually have to provide 3 different dictionaries if you want to specify things in that way. And it could be like the same dictionary with query params or something like that. But and the browser will only advertise to an origin 1 dictionary at a time. It will be the best match that it picks. So you can't have like 10 dictionaries for /* and expect the browser to advertise all of those and the server to just pick the best one. To avoid complications on the varies and caches and stuff, we restrict it to the browser picking the best match it can identify and only requesting that one, so we don't end up with too many copies and caches.
Awesome. Thank you so much, Pat. Everyone give Pat another round of applause. Great job.
Thanks.
You did a great job.
Thanks.